This is exercise 12.5, creating a box culvert. In this exercise, we will create a box culvert per TDOT standards and make the necessary updates to incorporate it into the 3D roadway model. The first thing we're going to do is create a new file in the Chapter 12 subfolder. And we're going to name it Road2BC Drainage Structures. And be sure that we are using the t.c2d seed file. Once the file loads, let's make sure that the default view is active in the lower left corner. And we're going to attach a few files. So we need to attach the drainage model, DGN, that we just created in the last exercise. We're going to attach the I-65 corridor. And we're going to attach the terrain. We're doing all these by the coincident world. And then we can fit view. And we need to set the terrain as active. Then we can zoom in to locate the box culvert created in the last exercise. So now we can turn off a few levels. So within the level display, and within the Road2BC drainage model reference file, we can turn off all levels other than the design model lines RCBC centerline level. And so now we're left with the centerline of our box culvert. So now we can open the Apply Linear Templates tool under Open Nose Modeling, Model Detailing, and 3D Tools. Next, select the centerline of the box culvert and then select the RCBC single template under Linear Templates and then Box Culvert and Slab Bridges. We can toggle on Lock to Start and Lock to End. Then we can start left-clicking through some prompts. And then when you get to this one, make sure that the reflection shape is placed on the bottom of the screen. So that makes sure that the point name will be on the correct side. Then continue left-clicking through the prompts. So now we have a linear template, but that linear template that was just placed needs to be modified to fit the dimensions of the proposed 8-foot by 8-foot box. We'll need to edit the template to match what was created in the last exercise. For this scenario, reference the standard drawing 17-53. And note that if a 3D modeling is being done by someone other than the hydraulics engineer, the information from the applicable standard drawing should be given to the 3D modeler. So we need to know that the cell height is 8 foot, the cell width is also 8 foot, the ST or top of slab width is 9 inches, the SB or bottom of slab width is 9 inches, the WT or exterior wall width is 8 inches, and BW or out-to-out width is 9.33 inches. So now let's open the Edit Template Drop tool under Open Nose Modeling, Corridor, and Edit. And notice that there are 5 yellow points. These points are only constrained in one direction and control the point described. So now we need to update the vertical constraint to 0.75 for a couple of these points by double-clicking on them individually. So first one we need to do is the RCBC SB control, which is the bottom left here. So go ahead and double-click on this point. And we're going to update this constraint one value to 0.75. And then apply and close. And the second point is RCBC ST control, which is the upper left one. So again, double click and then change the value here to 0.75. This template has been set up as a 8-foot by 8-foot box, so the other 3 yellow point constraints are already correct. The height would be controlled by the HT control point, the width will be controlled by the WD control, then the structure width would be controlled by the WT control point. So we can go ahead and click OK in this window, and it will automatically close. The model will reprocess and you should see the updates. And note that all of these points can also be controlled by parametric constraints. So now let's go ahead and turn off the 3D reference file. And then also in the level display, let's go ahead and turn on one level. So within the drainage model file, let's turn on this outside edge level. And this will show the 2D outline of the box that was drawn during the hydraulic analysis. And we'll use this to help model the wing walls properly. And note that in this exercise, the box culvert is at a 90-degree skew. If it was at any other skew, you would need to create a clip shape to clip the 3D model. So now we need to draw some control lines for the wing walls. So let's go ahead and select the wing wall dash control feature definition. It's going to be under linear, roadway, model control 2D plan, and then drainage. Make sure we set it to active. And then we can open the line between points tool under open nose modeling, geometry, horizontal, and lines. And then trace over the lower left 2D wing wall that we drew in the previous exercise. And then we need to complex the two elements together, drawing away from the box culvert. Then we need to repeat that last couple steps for the other 3 wing walls. Now we need to open the profile of any of the complex elements that was just created. And I'm going to keep working with the lower left wing wall here. So the profile of this line will control the bottom of the wall, above the footing. So to find the bottom of the box culvert, create a 3D cut, and then select the corner placement method and then draw an area so that the proposed box culvert shows up sufficiently on the left side of the profile. So in order to snap to the 3D cut, open the level display, and then right click on the Road to BC drainage structure, DGN, default 3D reference, and toggle on snap. So next we'll need to create a level profile line for the wing wall footing that the template will follow. So go ahead and open up that profile line between points tool under open nose modeling, geometry, vertical, and lines, and snap to the beginning of the box culvert bottom, which is the second bottom gray line. We're going to set the slope to 0 and then snap to the end of the profile. And we're going to set the profile to active. So this lower left one should be around elevation of 691.77, which is about right. And these profile elevations are set to match the inverts of the box culvert. And then we need to repeat those last couple steps with the other 3 wing walls. And then the beginning of the box culvert left side needs to be around 691.77 as well, which looks about right. Now we're going to work on the end right. This elevation needs to be around 689.98, which looks about right. And lastly, the end left. And again, this one should be around the same, 689.98. So once we complete that, we need to place the linear template drops for each of the wing walls. So let's go ahead and open up that Apply Linear Templates tool once again under Open Node Modeling, Model Detailing, and 3D Tools. And then select the wing wall template. Under Linear Templates, Box Culvert and Slab Bridges, Wing Wall. And then as we're clicking through these prompts, we need a lock to start, lock to end. And then we need to set this reflection to the center of the box culvert. And then we need to repeat that for the other 3. Always setting the reflection option to the center of the box culvert. Now we need to reference both the Standard Drawing 17-11 and Standard Drawing 17-15 to determine the applicable dimensions for the wing walls. And these will be entered as the parametric constraints in the next few steps. From Standard Drawing 17-11, the big H or fill height needs to be 10 feet, the W or wall length needs to be 18.5 feet, the little h or wall height needs to be 6.5 feet, and then the ST needs to be 9 inches. Then from the Standard Drawing 17-15, we can see that the wall dimensions for both the 6-foot and 10-foot design heights, and then the dimensions that goes along with both of those. And that's where we're going to be transitioning from the 10-foot here to the 6-foot on the outside edges. So now we need to edit the wing wall templates that was placed and set the base height of the wing walls. So let's go ahead and open up that Edit Template Drops tool under Open Roads Modeling, Corridor, and Edit. And then select one of the wing walls. And then we can double click on the yellow WW height control point in the upper right here. And here we want to update the vertical constraint to 9.75 feet. And then once we have that, we can click Apply and then Close. And then we can repeat that for the other 3 wing walls. And then for each wing wall, there will be 4 parametric constraints to control the wing walls to match the TDOT standard drawing specifications. So let's go ahead and open up that Create Parametric Constraint tool under Open Roads Modeling, Corridor, Edit, and Edits. Then select one of the wing wall templates to create the first parametric constraint. Then to create the height control, we're going to use the WW height control constraint label. The start station should be 2 foot from the end of the box culvert, and then the stop should be at the end of the wall. Then we're going to set the start and stop values to 9.75 and then 6.5. Then we're going to repeat that step for the other 3 wing walls. So next we need to create the remaining 3 parametric constraints for each of the wing walls based on the table shown in the manual. For each of these constraints, we need to lock to start and lock to end. And I'm just going to work with the lower left and work clockwise here. Lock to start, lock to end, and then the first constraint label needs to be the WW toe control. So the start value here needs to be 1.92, and then the end needs to be 1.5. And you can see in the 2D that the wing walls are adjusting just slightly, but once we complete these 3 constraints, we'll look at the 3D model, and it should be looking correct. So again, 1.92 to 1.5. And then the second one starts the same, lock to start, lock to end, but this time we want the WW width control. And this is going to go from a negative 1.17 to a negative 1. Then lastly, the constraint label needs to be RDWYII control. And here we're going to go from a start of 2.5 to a 1.25. So now that we have all of those parametric constraints done, we're going to go ahead and open up this 3D model. Then within the 3D model, we're going to turn off the I-65 corridor. And now we can very easily see our box score and the wing walls. That should be designed to TDOT standards now. Now, one of the last things we got to add to the 3D model is we need to add a edge beam along the top of the box culvert. So this line is going to go from along the end here, which is going to go basically from the top of this wing wall to the top of this wing wall to kind of fill in the little gap here. So to do this, we need to select the curb control feature definition, which is under linear, roadway, model control, 2D plan, and then curb and gutter. And then we need to make sure that the create 3D automatically is toggled on. And then open the line between points tool under open roads modeling, geometry, horizontal lines. And then we're going to draw a line along the top of the box culvert, snapping to the WW back top lines from each wing wall. And we're going to do this on both sides. And again, let's make sure that that create 3D automatically is toggled on. So we're going to go from this line here is WW back top. So from there all the way over to the other WW back top. And we're going to do that for the other side as well. And you can see that this line here was just placed because we just placed it in the 2D view. So now we need to open the Apply Linear Templates tool under Open Roads Modeling, Model Detailing in 3D. And now we're going to select the Edge Beam Fill greater than 3 foot 6 inch template. And then we're going to select that control line that was just drawn. And then lock to start, lock to end, and then left click through the prompts. And with this reflection, we need to place it on the inside of the box. You can see that we place this little filler right there. Now we need to repeat that on the other side of the box here. And now the box culvert model is now complete. So the last item that we need to do is target the slope lines to the new box culvert model. So now let's go ahead and switch over and open the roadway corridor file, which is the I-65 corridor. And as this is opening, be sure to say no to compact database. So once this file loads, we need to attach that drainage structure DGM file that we just created. Then within that file, we need to turn off this design corridor graphics design level. Also going to turn off the survey file, turn off the post file. Clear up some of the levels there. So let's go ahead and select the wing wall control feature definition. Again, it's going to be under linear, roadway, model control, 2D plan, drainage, and the wing wall. Let's make sure that the create 3D automatically is still turned on. So now we're going to create some complex geometry that the I-65 corridor is going to target. So first, let's open the single offset entire element tool under open node modeling, geometry, horizontal, and offsets and tapers. We're going to set the offset to 0. Then we're going to offset the WW back top line on both wing walls. And we're also going to offset the curved back line on the edge template. W back top. It's this line. So we're going to offset that line and then the curb back line. And then again, the WW back top. And in this exercise, we're only going to show the upstream side, but the process will be the same for the downstream. So now we're going to open up the complex by element tool. And we're going to set the method to manual. And we're going to complex the 3 of these elements that were previously drawn from the bottom of the screen to the top. And with the purple arrow pointing upwards for all the elements. And note that in general, complex elements do not need to connect. In this scenario, it is not an issue that the complex elements is still 3 separate elements. This step is done so that the corridor has a single element to target in the following steps. So now let's go ahead and open up the profile of that complex element. So be sure to complex these elements and then set it as active. Now let's open the create end condition exception tool under open node modeling, corridor, edit, and edits. Here we're going to select the I-65 corridor. And we're going to name this constraint as box culvert left. And then the apply ECE is left override. When selecting the start and stop stations, do it right at the beginning and end of the wing walls, but do not snap to the actual wing walls. Your stations may vary a little from what I have. So I'm going to start this right there. And then I'm going to end it about right there. So now you should have this window appear. So double click on that end condition component. And here we want to change the target type to linear both. And then the linear target to target both. And then apply and close. And then click OK to close the edit template window. So once the edit template window closes, you may notice that the end condition disappears completely, or perhaps nothing changes. So there are a few more steps for the corridor to target the complex element. So first, we need to open the Add Corridor Reference tool under Open Roads Modeling, Corridors, Miscellaneous, and Corridor References. Here we need to select the I-65 corridor and then select the wing wall control complex geometry that we drew. Next, open the Define Target Aliasing tool under Open Roads Modeling, Corridor, Miscellaneous. Then here you can select either the end condition exception or the I-65 corridor. Then within this window, we need to change the target drop-down option to target both. And then whichever WW control that you have in your left-hand side, go ahead and add it to the right-hand side. And then click Apply. Then it takes a minute to apply, and go ahead and close. So still not looking 100% correct. But that's because the end condition is only targeting the element every 25-foot template drop. So now we need to create a few different key stations. So key stations are under Open Roads Modeling, Corridor, Edits. Select the I-65 corridor. So then we can place a key station in each location where the wing wall changes directions. Also, additional key stations may be needed to get this corridor looking exactly correct. So I'm just going to place a few here and there, and as I do, we should start seeing some of the grass texture here, kind of fill in some of the slopes. And then you can keep placing key stations to get the 3D model to look exactly correct. This concludes exercise 12.5, creating a box culvert.